Alright, another mystery lighting control off eBay. What could it be? And does it work properly? Let's find out. Why? It's an LS100XA. A 100XA, which means that it has the lower light range of 10 to something foot candles, and it's never been installed, and it's still in the box, and it's got its instructions, and the wire niblets are attached. So this should be a fun one to check out, because we can give it a bit of an extensive check out. It's got a sensitivity adjust, it's got a deadband adjust, and it has a time delay adjust. And this one we can view pretty readily here in the office, because it's got a low enough range that we can manipulate the lights in here and get it to turn on and off and actually demonstrate how to set the deadband. So this should be exciting. Now we can see that this sensor is new, or at least has never been connected. We are going to use a BZ-50 power pack to check it, but before we do that, we're going to set the sensitivity down to minimum, because I'm going to be putting a box over it. And so we feel with our little tweaker very carefully where the stops are, and do not be forceful at all. Not at all. So we're going to set it down near minimum, which is 10 foot candles. This has a range of 10 to 200. We're going to set the deadband, which has a range of 10% to 100%, down to approximately 10%. Feeling all the time for gently for those stops. So we're at about 10 foot candles, about 10%. The time delay we're going to set for fast. So the way this one works is clockwise is faster. So let me feel for the little control, and we are going to make sure this turns just fine, and we are going to set it all the way clockwise, which should give us a timeout of about 3 seconds. Now, that one's a little hard to feel, but that should be about it. Now, with the power off, I'm going to hook it up to the BZ-50 power pack. Okay, control to control, plus 24 to plus 24, 24 volt common to 24 volt common, black to black, red to red, blue to blue. Let's plug it in. Power pack initializes, light comes on, and we have a green light on the sensor that tells us that we are above our set point. Now if I cover the sensor, I get a red light that tells me we're below our set point, and you can see that the power pack is responding within about 3 seconds, and our LED is changing from green to red, turns it on, to green, turns it off. If I cover the sensor, the LED turns red, and within 3 seconds the light turns on, back to green, and it's off. Red, on, green, off. So we have a perfectly functional sensor, but let's take a look. Setting the deadband, its effect, the set point and the deadband. That's what we'll look at. Now I'm going to adjust the sensitivity on the unit to get us a usable range, and I'm going to turn the sensitivity up until I get some action out of the LED. It turned red, light turns on, hunky-dory. Now I can reduce, or I can increase the lighting coming into this area, and LED turns green, load turns off. Now we'll put a light meter down and examine exactly what's happening here. Now with the artificial lighting coming into the area turned up full, I have about 32 and some change on the light meter for foot candles. I'm going to bring that down to about 15 even. A little harder than it looks. There's about 15 even up, it looks like to me. Now I'm going to adjust this to just turn the lights on at 15. So LED just turns red and lights turn on. Now I'm going to adjust the deadband to approximately 50%, and let's see what happens there. Remember, our time delay is still set for about 3 seconds. So this would mean that with the lighting at about 15, we have a turn on. Let's take the lighting up, and we get a turn off. So let's try and find our turn on and turn off points. There's 19, 20, 17 and change, 14.6, light turns on, 15, 17, 18 and change, 19, okay, anytime now, my bad. So when we get down to 15 foot candles, that light should turn red. There it is at 14.8, and it brings the light on. Now I'm going to bring the lighting up, and light turns off, and we are going to come down and see if we can find 14.7, 14.8, light comes on, but now we have a deadband of 50%. So 18, light stays, LED stays red, light bulb stays on. 21, 22. Now we get the green, light bulb goes off. Let's repeat that. Bringing it down, there's 19, bringing it down, there's 16 and a half, bringing it down, there's 15, light turns on, bringing it up, 18, light stays on, bringing it up, 20, light stays on, bringing it up. Oh, that went way up to 32. Let's bring it back down and try again. 15.8, light stays off. 13.7, light comes on, so our turn on set point is still about 15. 19 stays on. 22 goes off. 22 is about the sweet spot. Why? 15 times 1.5, okay, is around 22.5. So setting our deadband adjust gives you the difference between the cut in of around 15. There's 18, 15.9, 14.1, the light's going to come on. So our cut in is about 15, but our cut off, there's 18 and a half, there's 19.8, there's 21, there's 23. Our cut out point is now going to be about 22 and a half, and that is the effect of changing the deadband. And why do we need that? Well, I'm going to set the deadband back down to minimum, which is about 10%. Now we can see that the light should still come on at about 15, 14.8, light comes on. Raise it to 19.5, light goes off. At this point, 16 and a half or so should turn the light back off. Suppose the sensor is seeing its own lighting, and we are right around set point. Well, here we go. You see, red wants to turn it on, Green wants to turn it off. This is the effect of insufficient deadband. The system is cycling, and that is the importance of making sure that your deadband adjustment works, and also that you've situated this sensor, because it's an open loop sensor, to where it cannot see a contribution of its own lighting. Now, prior to putting this business away, let's talk about the time delay and the state of California. This time delay is adjustable between 3 seconds approximately and 5 minutes approximately. Clockwise decreases it, counterclockwise increases it. You're going to get the same delay for turn on and turn off. And in the state of California, for this to be legally used to switch off a set of lights for daylighting, you are going to need to ensure that you have at least a 3-minute time delay set in the unit. So our little sensor works fine, but where can we use something like this? Well, you can use it indoors anywhere that you have less than 0.3 watts per square foot of LED lighting installed. That is, that the zone illuminated by the controlled luminaires, if you add that area up and divide the wattage by that area, if it's less than 0.3, you can simply switch all the lighting in a daylit area off. And this is an ideal sensor to do that with.